Hello everyone, welcome to this session. My name is Wycliffe, and in today's video we are diving into something that's going to kind of change how you use Google Earth Engine in R. And if you ever used rgee, you know how powerful it is. Like, it allows us to get data from Google Earth Engine code editor or Google Earth Engine servers, and we are able to massively crunch a lot of data even while in R. But you also know that Earth Engine's native method chaining can sometimes feel a bit heavy, especially with the $sign, $sign, which I think most of the R users, even though $sign can be used to call columns or to rename columns or something like that in R, but we are not so much wired for that. For example, if I can just load library like dplyr, and then I say iris dataset, and then, so as R users, we are so comfortable using things like and then, which is a pipe operator, and then maybe select where species is, filter. For example, you only want to filter where species is called Setosa, for example. So with that, you have only records where the species is called Setosa. Or we can say take iris and then group by maybe species, and then summarize things that are simple. Group by, then summarize, for example, mean, uh, mean sepal length, and then that takes the mean of sepal dot length, right? So you get the mean sepal length of every species under the species column. These are simple things that we do in R, and they are so intuitive, or they are so natural, right? But when it comes to rgee, I agree that we will be talking about Earth Engine, image collection, $sign, dataset, $SR, S2SR, $sign. So that can be so heavy or cumbersome, or a different paradigm of chaining uh, functions in R. So there is this beautiful package called tidyrgee. So you can think of this as chaining, piping rgee operations in the tidy way which we normally use. And this package is well maintained. You can see updates were done like 2 weeks ago, and it's been there for 3 years, and it's on CRAN. So you can trust using it in simplifying your rgee. So in fact, the author himself or themselves say that however, this syntax can feel unnatural and difficult at times, especially to users with less experience in GEE. So those are the chaining with the pipes and all that. Yeah. So the purpose of tidyrgee is to provide the convenience of pipeable dplyr style methods such as filter, group by, summarize, select, mutate, etc. using our language style of non-standard evaluation. So these are a package that I would recommend those who like the chaining thing with the pipe operator in R, which is the more natural way that normal or current or modern data scientists in R are using. So I will give an example of this using Sentinel-2 image. So we'll create some NDVI and then look at how we can do the chaining with the normal standard piping operator in R. Okay, so let's dive in. First, we will load the library rgee. Even though we are going to use tidyrgee, we still need rgee to link with the Google Earth Engine. And then we will call tidyrgee package. I already installed it. If you don't have it, you can just use it, install.packages as the authors suggest down here. Install.packages tidyrgee, or you can use the development version using DevTools or remotes install underscore GitHub, and then you provide this name. Okay. So once we have rgee and tidyrgee, we can also have dplyr to provide us with the pipe operator. So we will use dplyr. We load the dplyr library. As usual, we initialize our Google Earth Engine session so that we are connected. Okay, so we will start by getting a region of interest, and today we are not going to use map edit. If you follow my previous videos, I've been using map edit. There, I just want us to create a point and then buffer it. So the coordinates of our point can be anything, maybe 35.35, and then negative maybe 0.366. So that's a point. And then on that point, we create a buffer around it of maybe 10 kilometers or so. So, or let's just say 20 kilometers. So that is 20,000 meters. So that's our region of interest. We can center our map around that region of interest, and then zoom it to the scale of maybe 10. And this is our Earth Engine object. Then we can look at our map. So that map has been zoomed to that, our region of interest, and also to the level of 10. So we can add our region of interest. So that is map.addLayer, and then we add our region of interest, of which we can style it to look the way we want. So we can style it to have a color of yellow, and then we give it a fill color of transparent. And then we give it some weight on the weight so that we can see it. Something did not work well, so we want to see style. Geometry, okay, geometry does not have this style attribute or function. So we can cast this into a feature collection. Okay, so that should work. All right, so we can have a world imagery in the background, and then we see our region within the 10-kilometer buffer circle. So we will calculate the NDVI within this region. All right, and again, something to highlight is that tidyrgee is currently working largely with images, not vector. So feature collections, we still have to deal with the dollar signs, but with images, with some properties, we can do the tidy version of them. Okay, so let's get the Sentinel image, which is an EE image collection. And then from the image collection, we call for dataset. So calling for this dataset, we can still use, as to SR, we can still use the normal ID of the image, or we can use this chaining to get it. I prefer this because it exposes us to a lot of data and we can choose which one to work with. And as usual, we are interested in removing cloud. So I will use image collection and then dataset again, and then we go for cloud score. Okay, so we have the two datasets. All right, so we can then create an NDVI for this region. Then we'll play around with the NDVI in a chained version. So to have our NDVI, we can say we take our Sentinel-2 image as we normally do this. After taking Sentinel-2, we filter bounds. We filter bounds using our region of interest. After filtering bound, we can filter date, for which we can pick dates of our choice. Maybe we want it from 2022, January 1st to say end of 2024. So that is 2025-0101. Okay. Then we, as usual, we can link collection, which will help us to mask out the cloudy pixels, and that is the CS plus, and the band in this CS plus, which has the ability of masking out cloudy pixels, is called CS. After that, we can map a function, and the function we are mapping is a function which takes an image from the collection. And after taking the image from the collection, it picks out a quality assessment band from the collection from every image which was linked. So we select the CS, and then the image will therefore be the image, but after we have masked out everywhere where the quality assessment is greater than 0.6. Okay, then we can now we have clean images or non-cloudy images, and then we can create NDVI, which from our clean image we can use normalized difference function, and then we provide it with a vector of bands to use, which is band 8 and band 4. Okay, then whatever it returns, we rename it as NDVI. All right, so that NDVI, because we will need some filtering to be done, we need every NDVI created from every image to contain time information. So we copy properties from image, and that properties is the system time start. So we cast it to list, and we say the list is system time start. So the beginning or the acquisition time of each image. And then from this, we only pick that single band, NDVI. That should run without any problem. We've done that a million times in the past, if you look at my recent previous videos. All right, so these all dollar sign things, we get a bit tired of them. But now what we have here is images which have been filtered to this region, have been filtered across some time, and now we want to do some other analysis with them. So to use this tidyrgee package or functionalities, we can first convert this image collection. If you look at this NDVI, if we run it on its own, like Control Enter, we see that it's an image collection, but it's an image collection which basically consists of bands. So there can be several bands. Let me check how many are they. So we print size. That's an @engine number, so we can get information from it. And we see there are 218 NDVI images, right? So those 218 are spanning the period 2022 to 2025 over this region, okay? Now, that kind of data, we can pass it to tidy format. So we can say NDVI tidy is as tidy EE. And then we pass our NDVI. So after some time, our NDVI will be in a tidy format. Once we have NDVI tidy, if I click on it, you will see a different thing. It will now not be the normal Earth Engine object, but it will say something like, okay, I know I came from Earth Engine image collection, but I also, all my attributes have been wrapped into a tidy format where we have a table showing us again that there are 218 images with 8 attributes or columns, right? So, and the class of that object is a tidyrgee object. So here we see even the dates when each of the images, the time start of each of the images. And even from this, you can clearly see that Sentinel image, Sentinel-2 satellite captures images every 5 days. So you can see first, then 6th, then 11th, so at an interval of 5 days. Basically, it captures the images at almost the same time. At around 8:10 in the morning, it passes maybe some seconds of difference, some differences in just seconds, but 8:10, it takes images from this location passively, right? And there are some other variables like system index, date, year, band names that are not shown here. Of course, if I expanded this region and I also expanded this side, then we could see more of that information. So the months, January, all these were for January. And then from here, it is the second month, February. And these were all for the year 2022, day of the year, the first day of the year, the sixth day of the year, and band names are hidden as a list here. And here we have only one band, which is the NDVI, right? So this table, we can play around with it the normal way we play with data frames. We can do group by, we can do summarize, we can mutate, we can do a lot of things. And then we can even throw it back to an image collection if we wish to, okay? So let's have a look at that image again, or that output after converting it to tidy, after passing it to tidyrgee function as tidyrgee function. We see that we have some dates here. So imagine here we have 2022, but we know all our time period, and it's even captured as a date data type. So super seamless conversion from Earth Engine object to tidy data. Now, with this date, we can filter and only retain NDVI of the period we are interested in. For example, if you want images that were captured after maybe 2024, then we can do that in this simple way. We can say NDVI tidy, and then, or we can call it recent NDVI. We can say recent NDVI is equal to NDVI tidy. And then, so we just like we were trying with the iris data, filter what? Where date, because we have date as one of the attributes, is greater or equal to 2024, maybe 2024, January 01. So here you will now have only NDVI images that were captured after that date. So if you look at this recent NDVI, let me rerun it, you will see that all the images here have got dates after 20, including that is greater than or equal to 2024-01-01. So we have 2024-01-01 and above. All the other 2022, which we were seeing before, have been filtered out in a tidy way. Yeah. If you want, for example, to filter for specific months, right? We can see that here we have month 1, month 2, month 3. Let's say you want only for maybe month 6, 7, and month 4, or month 4, month 6, and 7. Very, very, very similar. So maybe a certain seasonal NDVI. We can simply say NDVI, which is already tidy, and then filter what? Filter where month, because we have month as one of the attributes in that tidy table, in, okay? So we have this in, within which we can provide a vector of values. So maybe month 6, month 7, and month 8, for example. Yeah, so this will only return images that were captured within this period of time. So if we check seasonal NDVI, you will see that none is outside 6, 7, and 8 as the month. So the months, so the NDVI images we will be having are only for the months 6, and then others are 7, of course, until 8. There are no other months that are left, that are kept. So here you can simply pipe, you see, you can simply pipe your functions the same way we do with iris dataset or a data frame, regular data frame in R. Let's say you want to do some monthly statistics. Probably this is more interesting. So we can take our NDVI tidy, our tidy NDVI, and then we can filter for some year. Let's start with filtering. When we say year, for example, you remember that our original NDVI was from 2022 to 2025. So we can say we only want those that are between that are between 2024 and 2020. What was that? Yeah, let's say 2023 and 2024. So 2023, we only need, and 2024 images, okay? But not only that, and then we want to get maybe monthly data per year, right? Again, important, if you look at NDVI tidy, we have columns. These columns, date, month, and all that. We also have 3 more columns, and those are year, day of the year, band names. So now we are using month and year columns, right? Okay. So we are using month and year column as the grouping columns. So year and month. So we want for each year, we group and we get a statistics for a month. Then we summarize, just the same way we group by and summarize normal tables. Let's say some statistics, and to that statistics, we can provide a list. Maybe we want the mean, we want the standard deviation, we want the minimum, right? We can get that in this monthly stats, just like that. So if you look at monthly stats, it is a table of 24. Remember, this is 2 years, the whole of 2023 and the whole of 2024. And on a monthly basis, then we will have 12 images for 2023 and 12 images for 2024. So it's a table of 24 by 8 columns. So for the year 2023 and for the year 2024. So it has done the summary, and we can convert this back to an Earth Engine object and visualize it if we want. We can also do this for multiple statistics, more than mean, standard deviation, and minimum. So we can just say multiple stats we can get by our NDVI tidy _tidy. And then we filter maybe for the years greater than or equal to, or even for 1 year, let's just say 2024. And for that 1 year, we can just provide it as a number because it's recognized in the data frame. Then group by, or in the table, group by, we can group by month for this year. If we just want the monthly NDVI for summaries or some summary statistics of every month for the year 2024. So we can say start is equal to at least, or we can even provide it as a vector of mean. So this is one of the statistics we want. Another one could be median. We can still get the median statistics. We can get the standard deviation. We can get the minimum. We can get the maximum. All these NDVI values we can get. If we run that, we now have month mean NDVI for 2024, median NDVI for 2024, standard deviation NDVI for 2024. Everything here still happening back in the Google Earth engine. We have not downloaded any image. Okay, so let's look at multi-stats. Perfect. So they are only for 2024. Now we don't have 2023. And the months, because they have been grouped, some months have more images than others. For example, February normally has less days, and therefore we expect less images. Days with 31 days, sometimes slight differences in the number of images that contribute to its median, standard deviation, and all that, right? So all these we can chain without any sweat. We can pipe using the pipe operator. We are not using any $sign within this piping or tidyrgee format. So we can create from these multi-stats, we can create, or even the monthly stats one, which is a bit less small. We can create, I think it doesn't matter. We can create, we can throw it back to an Earth Engine object. So we can say monthly Earth Engine is equal to monthly stats, and then, right, as Earth Engine, as simple as such. That function wraps up whatever we've been doing locally, comfortably in our tidy format back to an Earth Engine object. And now what we see, if we run this now, is back to an Earth Engine image collection. And in that Earth Engine image collection, we can print it. For example, print monthly EE. We can print that. It takes some time, and then we will be able to see the output of this monthly Earth Engine. What do we expect? Because that's even more important. We are filtering for the year 2023 and 2024, and we are grouping by year and month. So we are expecting 24 images because each year has 12 months, and we have 2 years. So it's coming up. We just give it some little time. Perfect. So as you can see, we have 24 images, number of images for 2023 and 2024, and they are all NDVI images. Okay, so we can do what? We can visualize any of these we can visualize, for example, the first one, because these are NDVI. We can say map $add layer. Okay, here we still don't have the piping into add layer, so we still use because we have gone back to the Earth engine. So we can pick the first one, doesn't matter where it is, and then we can clip it to the region of interest, and then we can provide some visualization parameters, a list with a minimum set to maybe 0.1 and a maximum set to maybe 0.8 stretched there. And then for the palette, we can say take some 3 colors running from red where it is very, very low to yellow where it's a bit medium and to green where it is super good. That should not take too long because it's a normal visualization. We are seeing we have more than one band because we calculated some mean, standard deviation, and minimum. Okay, so we can select, say, mean. That's a good one. Okay. When the mean, median, standard deviation, and all these are calculated, they are appended with the term NDVI. So, which was the name of the original image. So we can say NDVI mean. That's the name of the band, not just mean, but with NDVI. We could also check the band names if we wanted, like after picking the first, then you ask for the band names. All right, so we have enjoyed doing rgee relatively simpler by moving all the way from the rather user unfriendly chaining of $, $, littering your screen to more user-friendly and then group by and summarize, and then even throw it back to an Earth Engine object and make a visualization of what you've been calculating. I think this is a good improvement. It's been there for some time, but it's good to know for somebody who has been bothering about the $. You can prepare your image, and then after that, whatever you do with it, selecting whichever months you want, whatever functions you want to reduce the regions to, whether you want the mean, median, standard deviation around some region of interest, and then you throw it back to Earth Engine and proceed with the visualization or exporting or something like that. Okay, so that's all I wanted to share with you today. If you find this interesting, you can try it with your code and see how it progresses. Remember to cite all the packages and data sources you use in your work because their creators take a lot of time. Big shout out to the author of this package, tidyrgee. That is Anozak and Erickson J. This is the way to make the life of our users with Google Earth Engine simple. As they mention in the description of the package, it is providing the convenience of pipeable dplyr style methods: filter, group by, summarize, select, mutate, etc. I agree, that makes life a bit simpler if we can work with a tidyrgee package. Okay, thank you and happy coding. Bye-bye.